Let's move on to the next presenter for the day. We have Hariket, Sukesh, Kumar, Sheth from second year CSE.
Thank you, Dodi, for the introduction, and Tripti for giving an informative session on big data and analytics. So I'll share my screen first. Yeah, so hey everyone, I'm Hariket Sukesh Kumar Sheth, a second year BTech CSE undergraduate. So I'll be delivering a session on this topic, which is DevOps and NoSQL databases. So now DevOps would be, I think, a much familiar term to you, or might not be, but I'm sure maybe by the end of this session, you will have a basic idea about what is DevOps. So moving forward, this is the planned agenda for the seminar where where I'll be discussing about software developmental cycle, what is DevOps and how is it useful, and then we'll move forward to NoSQL. And then in the last, we'll hear out to your discussions and any talks if you want to do. So let's get started. Have we ever thought how softwares are built? We generally use a lot of softwares in our day-to-day life, be it Microsoft Teams, be it Google Chrome, or it might be Zoom, Google Chrome, Google Drive, AutoCAD, CorelDRAW, and the list goes on. So we use a lot of softwares in our day-to-day life. Have we ever given a thought how is it made or what the process was involved in making that particular software? If not, let me introduce you to that particular process. So in every software developmental company, we have a particular development team, which is responsible for coding part, as in they are responsible for writing the codes, writing functions, building functions, and all those things. And then we have a particular testing team in the company, which is responsible for testing out that code based on some conditions, some constraints. It will see whether this code is working on all the conditions, and then they will approve. If they don't approve, development team again works on the code and improves it further. Passing on this particular section to the operations team, their job is to actually deploy this particular code to an public server or public application such that it is visible to all. So if I give an example, your project, if it's deployed on a website, say github.com or github.io, so that is in public URL. You can share that and everyone can see that particular website. So operations team task is to deliver the product built by the development to the end users. So the apps you see on your Google app or even the website you download a lot of softwares and apps. So all of those tasks are like operations team handle these tasks. So you understood the process, but then where's the problem? You heard about development team, you heard about testing team, you heard about operations team. Everything is well defined. Now, where's the problem? So this is a particular scenario where the problem is occurring. As in, you can see the development team has completed its software. It is passing their files to the operation team, but the operation team is saying that it doesn't follow a particular guidelines. Maybe it can be company guidelines or it can be some coding guidelines. It can be anything. So they are saying it's not following the guidelines. So now what will happen? What do you think what will happen? So development team has to again redo whole of the work and they have to follow those guidelines and again deliver it to operations team. It is not an easy task to redo the whole work again because not only it will waste time, but it will also waste resources and it will also give a bad impression on the customers because this process, if it gets much delayed, then the customers would have a bad impression about the company delivering the software. So that's where DevOps jumps in. And also before that, I like to explain that there's a wall of confusion between the development, testing, and operations team. As you saw that if that there is no point of communication between both the teams, the development team works separately and the operation team works separately. Until and unless the task of development is completed, operation team doesn't have any idea of what is going on there. So this creates a wall of confusion between them. So development team works on a task, testing team tests it and then delivers it to the operations team. They check it, they approve it. Now development team works on task 2. They deliver it to operation team again, and now they find a fault. Suppose they find a fault. So they will again send this particular code to the development team, and then they will notify that, yeah, there's an error. So both the teams now will waste time on discovering or finding out where that particular error is happening. And this will not only waste time, and it will also waste resources, as I mentioned earlier. So what is DevOps then? So DevOps is actually like, I will request everyone to listen this particular statement carefully. So DevOps is a combination of practices and tools designed to increase an organization's ability to deliver applications and services faster than the traditional developmental process. So what is this traditional development process? Where you have separate teams, development, operations, testing. In DevOps, you have a collaboration, as in all these teams work in collaboration, and the speed enables the speed which you get with this collaboration is serving the organizations to better serve their customers and compete more effectively in the market. And in simple terms, if I may explain, DevOps is about removing the barriers between the traditionally DevOps teams, as in the already allotted teams, development, and all those things. So this remove the barrier, and both the teams work in collaboration with each other, removing this so-called wall of confusion between them. And this is what we call as DevOps team. So some of the benefits of this DevOps is that one of the thing is speed, and the second one is rapid delivery. Now why am I focusing more on speed and rapid delivery is because in these days you might be aware that a lot of competition is there in the market. You would be finding updates in your Google Play every day. Almost every day you will be asked to update your Microsoft Teams, WhatsApp, Instagram. You will get enormous updates. Even I can even give an example that in a day you might get 2 updates in your Google Play for a specific app. So that is how huge the competition is in the present market. So now if you are not able to resolve your internal conflicts in the company, it will obviously reduce the efficiency and also give a bad impression in the market that this particular company is not able to deliver applications faster. So that is why speed is an important factor, where you have artificial intelligence, you have big data analytics, as Tripti covered, you have machine learning. All of these things have to be integrated, and a new feature has to be brought into the market. So all of this needs time. So this alone needs time. Now, if you are taking more time in development and like resolving these conflicts, it will again add to that time. So that's why rapid delivery is a thing. Then reliability is also a thing. Now, when you collaborate, when you have like all the logs mentioned, as in you know what operations team is doing, what development team is doing, there would be no mutual fights or there would be no mutual confusions. All of the teams would be aware of what particular thing has to be done, what process has to be followed, and what other common mistakes they might be facing in the near future, so they can work accordingly. So the DevOps practices are like more focused toward continuous integration and continuous delivery. And it is also secure. As in, if you adopt a DevOps model without sacrificing security, you have like a better security version and model development. So moving forward, now we'll look. So this is how actually the DevOps team in every or like most of the software development companies look these days, wherein you have some people from the operation team, you have some people from development team, one testing guy, or it may depend, like the number of people may depend. And then you have also people from the security department. So instead of saying this as DevOps team, we can also term it as DevSecOps team, where you have a person who is ensuring that your code is also secure, as in you're not exposing the sensitive data to the public. Everything has been kept privately and stored privately, and everything is encrypted over the network. So this is how DevOps team look, where you have all the people in a specific team. So all of these teams work on subtasks, as in every team has a subtask to work on, and then they work and collaborate and they finalize their final product, and then it is delivered to the final customer or any organization which they are partnering with. So this is basically your DevOps cycle, as in also I can say it as DevOps phases, where you have 8 steps. So moving with the first step. Now before starting with this, I like to tell that this particular cycle depends on company to company, as in they have specific cycles to follow, and but this is one of the most common and most accepted one. So in this first phase is planning. Now DevOps is not, again, I am talking about software development companies. It's not just limited to your companies. It is even applicable to your day-to-day projects you're doing. You might if you employ this in an early stage, it will actually, you will realize the benefits of this DevOps. So first of it is planning. Planning is very important because planning stage covers everything that happens before the developers start writing code. Now, it's where I think the product manager or like project manager earns their keep, as in the requirements, what the customer wants, whatever are the features that have to be worked on, what are the resources available, what is the time constraint, everything has to be done and taken into consideration in this planning phase. Then moving forward with the coding phase. So once the team has grabbed their coffee cups and they have like ready to work on their task, they get to the work of coding. Now they select the tech stack and they start coding, and then moving forward with the building task. As in this build phase is where the actual DevOps kicks in. Planning and coding is just very, I would say, normal. It is not something new, but building is the phase where DevOps actually kicks in. So once a developer has finished the task, they commit their code to a shared code repository. There has to be some common thing where you are committing your code, because in the team you have multiple people, right? You don't have only one person working. You have might be 10%, 20% working. So you should have a common repository, a common thing where you are sharing the code, you are sharing your updates, whatever is happening. So this is how actually build works. And then you have automated tasks, as in you perform tests whether the code which you have written is perfectly working on specified tests, or whether it's failing on particular tests, so you can work on that. Even you can also check here about the security, whether the code base you have, like code which you have written is secure and following all the guidelines. So if at all any test fails at this case, you can see a recursive arrow over here. So if at all any case fails here, it again goes back to the coding phase, again build and again test. So once all the tests pass, then only it is forwarded to the release state. Now, release state is a milestone in DevOps pipeline, if I say so, because it's a point where you can say that build is ready for deployment into production environment. And this is also where actually it enters the task of operation team. So depending on the DevOps maturity, as in how long the organization has been following the DevOps model, they choose whether they want to automatically release or they want to manually release. Okay, so if I give an example, I would like to give an example of WhatsApp, as in you must have heard about this dark theme, light theme. A lot of hype was going on these days, in the previous days. So you might have encountered a situation where some of your friends got that dark mode earlier and some of you didn't get that dark mode even after updating it from the Play Store. So how did that happen? So specific companies have so-called feature flags where they turn off feature flags. They decide which users will get these features in what particular time. So they actually decide based on those feature flags. So it depends on company to company whether they want to make that feature applicable or public to everyone, or specific user, specific country. They have that particular job in their hand. So this is how releasing works, and then the deploying. So deploying is again a big time, as in this is the main process again, because you might also have this situation in your hand where the code works in your system, but it doesn't work on the website where, or even the software or server you are deploying it on. So this again has to be deployed on a very particular secure server, which meets all your requirements. And then coming up to the operation phase, where the new release is now available to the customers. So the operation team is now hard at work because it makes sure so that everything is working smoothly. Based on the configuration of the hosting service, the environment automatically scales and handles the peak, because operation is the phase when it is publicly available. So everyone visit that website. So they have to monitor the traffic on the website. So this is where operation team task increases a lot. So they have to keep their, so they have some mechanisms to actually get the customer feedbacks whether the website is working fine or not. So, and you all must be agreeing that no better testers than customers, as in the users. If I give you one website that I have made it, and if I tell you just analyze it, you will all come to me, as in you will contact me via WhatsApp, or you will call me that this particular feature is not working. So that is how I will also get to know. You will also see some of the softwares like Microsoft Teams. People do post on it every day on websites, Reddit, and all of those things. So that's how people get to know that, yeah, this particular service is not working at this particular time. So yeah, this is where actually the testing also works, as in the feedback is taken from the customer. And then it's very important to monitor also. As an operation task is now, you can say that it's the end of the task, as in the end of the phase. And this is where the company moves on to the second task or the second project. But should they stop monitoring the first project they worked on? Obviously not. If you stop monitoring your projects, the previous projects, the first project might reduce the efficiency. Like it might not be able to meet the customer needs and demands. So you have to also monitor your previous projects. So this is just one iteration which I showed you, wherein you have planning, coding, building, test, release, deploy, operation, and monitor. This is just one iteration. You have a lot of iterations going on in the software development company. So now coming up with the one thing which I mentioned about your continuous integration, delivery, and deployment. So you have specific terminologies for this thing. As in DevOps is all about continuous things. As in you will see continuous is mentioned in everything here. So continuous integration is again one thing which I covered in your building or testing part, where continuous integration in your building part, because uh, when you push a code to your repository, there has to be specific mechanism that checks that whether this code base is particular or right or not. Because you must be working on project with 10 of your friends. Now, how will you discover that your particular friend is writing the correct code? He's maintaining the tech stack properly. He's writing the syntax properly. So you have to have some kind of automation or some kind of task that has to be performed before that code is pushed or that code is merged into the main repository. So this is where continuous integration comes, and continuous delivery is more as an extension of continuous integration, which automates the task of processing a new build into production. And then comes continuous deployment, which is an advanced version of continuous delivery. So it is mainly responsible for checking the balances of pipelines, as in automatically deploying the code base to the website or server. And then you have this particular thing where you have softwares mentioned. So for coding, you have Git, Jira, and for build, you have Maven, Gradle, SBT. For testing purposes, you have Selenium, JUnit. For releasing, you have Jenkins, CodeShip. So you have specific softwares to learn and specific, what you can say, systems to learn, as in these are the systems which will help you in this particular phases. So this is not all, as in the previous screen which you saw, this is not all. So if we have any particular chemistry fans in the audience, let me show you this. So you have this whole periodic table of DevOps tools. So you can see there are so many tools for you to explore and learn. Now, when I said that, it's not again important that you have to know everything in this world. Okay, it's not important that you should know everything in this world. You have particular situations, you have particular needs. So you should select the best software and you should try to learn that and yeah, achieve your task. So this is just an overview that there are a lot of tools available in every phases. So yeah, then the story doesn't end here, as in DevOps is not just the only thing. Depending on your particular use cases, as I said, you have ML DevOps, or it is also said as ML Ops. Then you have data ML DevOps, and you have data Ops and AI Ops. So again, these are the developmental cycles, or the, you can say, the processing tools, the phases which are followed when you're working with ML, AI, and data. So this is how it is followed. And then now we'll move on with the database. So if at all, I don't think anyone would be unfamiliar with databases, but still. So if you don't know about database is just an organized collection of data so that it can be easily accessed and managed. So depending on the type of data is stored as fields. Either it can be stored as fields, collections, or it can be stored as tables, rows, and columns. So that also brings us to the types of database. So we have SQL databases and NoSQL databases. So SQL database, which are the relational databases that actually concerns with storing the data in the form of rows and columns. Whereas in your NoSQL databases, the data is stored as collections or schemas, or you can say it is also stored as fields. So only I'm just specifying one of the disadvantages of both the things. As in SQL databases, you have vertical scaling. So what does this mean is that vertical scaling means it increases the size. You can see how it is increasing the size. So in the form, like when you're expanding your SQL database, it actually vertically scales. Whereas in your NoSQL database, it is horizontally scaling. So if I may ask you in the audience, you will obviously select horizontal scaling over vertical scaling for some particular use cases, because like considering whatever Tripti presented, big data and analytics, horizontal scaling is very much appropriate, because you vertical scaling needs a lot of, again, monitoring and all those things. But again, it's not like I'm discouraging, or I'm just what I can say, I'm just disadvantage proving that SQL is not better. It's not like that. But this is just one disadvantage, that NoSQL database are horizontally scaled and SQL databases are vertically scaled. So you can place simultaneous machines in like side by side. That is how horizontal scaling works. So you can actually access a lot of data, and uh, in horizontal scaling systems, you can access a lot of data simultaneously and store also. So then coming up with our discussion on this particular NoSQL databases. So as even again, Tripti mentioned about the big data analytics. So we have 74 zettabytes of data, as in this is just the approximate amount of data which will be created or is actually created by the end of 2021. So what does this mean? When I said that figure of 74 zettabytes, what do you actually incur or infer from this? So every zettabyte is actually equal to 1 trillion GB, which means 74 zettabytes is equal to 74 GB of data. Now, if I say that figure, that might look like a little low to you, because I'm just saying 74 trillion GB, but it is actually a lot of data. And in the world today, we have 1.18 billion active websites. So imagine finding one website out of these, imagine finding one website out of this, which has a particular image, which has a particular software, or which has a particular game in which you are actually want to search. So it will be very difficult to search that. Now you will say that, okay, I'll search it using a search engine or so, but again, finding a particular text or particular image, it will be very tough. So then going forward, we have like, as I said, yeah, it doesn't sound easy. Handling and storing data is again very difficult in this world. So this is the challenge which almost every big company and MNC is facing, as in handling and storing data in this particular world. So I'll be covering about what is the application of NoSQL in Industry 4.0. So when I said that Industry 4.0, it's nothing but an abbreviation given or a term given to the fourth industrial revolution, which just conceptualizes rapid change, and it is more like working towards smart automation tasks. So then Industry 4.0 is actually moving now towards Industry 5.0, which actually allows the customers to customize what they want, right? So big data and analytics is actually regarded as a technical pillar of Industry 4.0. And since the data-oriented paradigm has shown to be crucial and for the technological transformation process, a number of system design concepts have been reported over the years. And it is also like to achieve the so-called smart factory in this data-driven world. So many of these concepts handle data storage solutions as though they were just another component of the architecture. So choosing a logical data model is very important. It's very important because this defines your system performance, your system testing, or the how your system would perform when it is actually exposed to the real world scenarios. So choosing this logical model is very important when you're working with this big data or analytics, as you say that. So sustainability is again a factor, and again, what the parameters it will be covering and all those things have to be kept in mind, and you have to choose the particular logical model. Then these are some of the challenges which a particular person faces when he has to build a website or a software, where he has to manage the availability of fresh and constant data, as in you have new data in your hand, and he also has to ensure that older data is also available to him, as in not just the newer data, but also the old data is also visible. Then generate the website based on patterns and analysis. Now we'll cover that in the later part. So keeping the website performance at the bay, because if your website is going frequently down, then your customers would feel that, yeah, this company is not able to actually monitor or operate the website properly. So you have to keep up your performance of the software at the top, at the peak. So moving forward with the sixth point, which is possibility to add and reduce category. So as in you are adding and also deploying a lot of features which your customers are suggesting, that is also very important. So these are some of the challenges. And apart from this, like NoSQL can be used in all of these specific domains which are specified in front of you, as in detecting fraud and e-commerce. It can be digital data, mobile data, communication, IoT, e-commerce, full stack development. This is also very important. In the front end, you can have mechanisms for storing the data. And in the back end, you have mechanisms for actually conducting analysis. Now, you will have this particular website of maybe gaining customer feedbacks. So if at all you find that, yeah, people are not very much happy, so you will actually have a mechanism or machine learning algorithm at the back end that can actually tell you or notify that, yeah, customers are not happy lately with this particular feature. So you have that analysis pattern deployed at the back end so that you can perform some analysis. So, and in the below, you have 4 types of NoSQL databases: document, key value, white column, and graph. So these are types of NoSQL. Now coming up to the very common and like, yeah, much familiar examples of your NoSQL use cases, you have Facebook Messenger, or I might say it as Meta Messenger these days. So it uses Apache Cassandra, which is again a NoSQL type of database, which has the ability to list all the messages sent to a particular user, and it indexes the user's messages based on ID. So it actually is very much responsible for storing the user messages and all those things. So Apache Cassandra is widely used. Then moving forward with your, again, second common example of LinkedIn, which uses Hadoop for actually generating the connections. When you open LinkedIn, you will see that you are getting information about possible connections in your your feed. You will be notified that this person might know you or such kind of data. So you will get some of the thoughts in your mind that how is it actually generating such data. So Hadoop actually churns that information overnight and pushes this latest graph information to your account daily, and it works on an Voldemort key value NoSQL store to actually query all of the data overnight and maintains this rolling view of all the data in the service. And then you have Aadhaar. Again, no introduction I have to give for this. This is India's unique identification project. It actually uses MongoDB as one of its databases to store the huge amount of data. Now, MongoDB was not the only database, but it was one of the database which they used. Other database, they used MySQL also. So MongoDB has nothing to do with storing the sensitive data. They just are storing the photo or the photo related data or the demographic data in MongoDB. So moving forward with your Gmail, again, VITians would be using this on a daily basis. So Bigtable, Google's Bigtable is actually responsible for this, where a lot of applications are built, wherein it also includes Google Earth and Google Maps, Google Books, YouTube also. So Bigtable is actually responsible for that. And again, this is a very last example where you have two-factor authentication, or in simple words, we say it as OTP system, where additionally, apart from like entering your account password, you also get an OTP on a second device or a secondary device where you have to verify the code and so things just to authenticate the process. This ensures the security. Now you have a hocoraxic matching algorithm. As I said, you have these algorithms on the backend to actually query the malicious queries. Now there are hackers sitting, as in they have some kind of jobs. You must agree, right? So they are actually in the site of hacking your data, hacking your account every day. So actually this system is particularly what it's doing, that it's actually storing the malicious query in a Firebase DB. You can see here. So if it detects a malicious query, it stores that in the backend and it just doesn't allow the user to log in at that particular time. Either it will break the system, or it will actually like the server would go down, or actually it will give a warning message. Something like that would happen at that particular instant. So that is how actually it works. And if at all a query which is sent to the backend is not present in this DB, then only the user would be authenticated, which actually what concludes that it's not a malicious query. The two-factor is proper, the password entered by the user is correct, then only the user would be validated, as in he would be termed as valid user. So again, it's important to choose the right type of database, whether it's relational or NoSQL. No database is like, I would say, it's not superior, as in I'm not saying NoSQL is superior than SQL. Everyone has their own use cases. Everyone has their own scenarios to look upon. So choosing the right type of database is very important. So you should know what are the advantages and disadvantages of both the database, and then you should look upon that, what particular database you have to use. So this is just an illustration of what exactly is, how it looks. So this is how actually the iteration goes on in every development company, where you have a lot of tasks going on, and this is how actually the iteration goes on. I was not able to show that in the presentation mode, as in the animation was not there, but this is how actually it goes on. So you have a lot of tasks going on simultaneously, and yeah, this is how actually the scenario looks. And even like you will see that I discussed about a lot of applications in that particular presentation, but the only key takeaway which I can give you for this particular session is that at least create a GitHub profile. Like as a university student, you should have a particular, like at least a GitHub account ready, because these days it is becoming what I can say, it's becoming your resume, or you can say it's becoming like your LinkedIn, a second LinkedIn. And like put your projects up, put your whatever you're working, put it up on the GitHub, connect with people, and yeah, avail the student developer pack which VIT is providing you at a free cost. You just, what you have to do is you just go to this website, click on sign up, and it's not only just for students. We have faculties in the meeting as well. You can also like avail this facility where you can actually sign up for a developer pack, and you can actually avail this facility of applying to this. You have a lot of features given up for free. You can see Canva and all of these things, domains are given up for free. The only thing you have to do is register or sign up using your VIT email address. So you will get the benefits of this particular pack. So yeah, as a student, you should try to avail these facilities, and it's given up for free. So you should surely look into this and sign up for this.